Alright, welcome to the second derivative. This is my first time saying this at the beginning. If you think my video is helpful to your study, click the like, give me a subscribe. I appreciate your help really much. Alright, what is second derivatives? So let's start with some easy derivative. So let's say we have y to the x, not y to the x, y equals to x to the 10th. And then the first derivative, y prime, so that is 10x to the 9, right? The second derivative is the derivative of the first derivative. So you bring the 9 down, you have 90, and then 9 minus 1 is 8. You can keep doing this. You can find the third derivative, and then you bring the 8 down. So that will be 720 x to the 7. You can keep doing this. You bring the 7 down, take the x7 minus 1, you can keep going. So this is taking more and more derivatives. So find the first and second derivative of the function. So A, we have f of x equals to x to the third plus 1, and then e to the x, and then f prime of x. Ooh, what's the product rule? The product rule is fg prime plus gf prime, right? I will remind you every single time, but no one will remind you this on your test. Fg, so we have x to the third plus 1, the derivative of e to the x is still e to the x, and then plus g, e to the x, the derivative of the parenthesis is 3x squared. That's it. The derivative of 1 is 0 square. Alright, and then you have f prime of x that is equals to x to the third ex plus ex, and then plus 3x squared ex. So that is the end of the first derivative. And then the second derivative, you take the derivative of this derivative, but you want to make this as simple as possible. So one recommendation I have for you is you factor out the e to the x. So you have x to the third plus 1 plus 3x squared. Alright, do you have to do this? What if you don't notice this? You don't have to. If you don't do this, then you have a quotient rule in here and in here. Then you have no quotient rule. You have a product rule in here and here. So that means you need to do two product rules. If you do this, you only have one product rule to do because there is only one product. Ex times the stuff inside the parenthesis. So f prime double prime is not single. Oh, that one is single prime. My mistake. So that one is a single prime, and then this one we have a double prime. So we take the derivative of the parenthesis. So f and then g prime. So that will be a 3x squared, and then this is a 0 plus 6x, and then plus, copy the parenthesis, and then the derivative of f is still e to the x. To me, this is a perfect final answer, but the book wants you to go all the way to the end. Alright, we follow the book, so that is a 3x squared ex plus 6x ex plus x to the third ex plus ex, and then plus 3x squared ex. Looks like we can simplify these two, right? And then that will be a 6, but you still have a e to the x. It depends how you want to put it. You can put the ex out, and then the highest power is x to the third. So this ex is out, this is out, this is outside of the parenthesis. And then the second power, you have a 3 plus 3, you have a 6. And then the first power, you have a 6x. And then this one, you bring the e out, then you only have a 1 left. You don't need to factor out the e to the x. I don't think you will lose points if you don't factor out the e to the x, but it depends how you want to put the answer. All right. So there you go. Here are the first and second derivative. We have a rational function, so that means it is time to practice the first derivative. I use red once a while, right? So let's use red for this one. So we have g of x, number 2, we have g of x equals to x squared divided by 1 plus x. So quotient rule. Quotient rule is gf prime minus fg prime, right? Divided by g squared. Let's do it. G prime of x is equals to, we square the denominator immediately, and then gf prime, so we copy the denominator, and then the derivative of the top, minus, we copy the top, the derivative of the bottom is 1. So overall, what do we have in here? This one we have 2x plus 2x squared minus x squared divided by 1 plus x squared. Okay, so clearly we have 2 minus 1 that equals to 1. So we have 2x plus x squared. If you want the higher power goes first, so 2x plus x squared, right? 2x plus x squared, that means we have x squared plus 2x divided by 1 plus x squared. No. The square doesn't belong there. The square belongs here. That affects the next derivative. Can we take that as the final answer? That's why I picked this problem. If you take that as the final answer, yes, you can take this as a final answer. No one can take points off from you. But have you learned this yet? 1 plus x, the whole thing square. I haven't taught how to take the derivative of this yet because this belongs to a chain rule. I haven't taught that yet. So that means you have to expand the denominator for me. So this one requires a rule called chain rule. If you took calculus before, yes, you know what it is. But if you never took calculus before, you don't know this yet. Okay, let's expand the denominator. The top is x squared plus 2x. The denominator is 1 plus 2x plus x squared, right? It's not a big problem it's not a big thing for calculus people. And then you do second derivative. So second derivative, so g double prime of x, we have square the denominator, 1 plus 2x plus x square, and then we have gf, so we copy the denominator first, and then we take the derivative of the numerator, which is 2x plus 2, and then quotient rule is always a minus. You subtract what? You subtract fg prime, so x squared plus 2x, and then the derivative of the denominator, that is 1 plus 2x plus x squared. Wait, hold on. What did I do? Fg prime, right? So g prime, the derivative of the denominator is 2 plus 2x. This one, let's don't do the simplify. I will leave the simplify to you because the problem is asking for this g double prime of 1. That means you plug in 1 to x. So the bottom will be 1 plus 2 plus 1 square. And then this will be 1 plus 2 plus 1 square. 2 plus 2 minus 1 plus 2, and then 2 plus 2. So overall you have 4 times 4, 16, and then this is a 3 times 4 divided by 16. So you have a 4 divided by 16, that is equals to 1/4. That is g double prime of 1. But this part I leave the simplification to you. Right? It's very simple. Okay, so that will be all for the second derivative. In the last part, I will show you the tangent line and normal line.